This is Griffin again from the Villanova Math Learning Resource Center, and this is our third video in our Trig Tricks series. And in this video, we're going to talk about a really useful identity that will come in handy when you're doing integration in calculus. So this identity goes as follows. It says that the cosine of 2 times theta this is sometimes called the double angle identity. It says that the cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta. And let's think for a minute why this is true. Well, we could use, to prove that this is true, we could use the angle addition formulas. Because check this out. Cosine of 2 theta is equal to cosine of theta plus theta, which is equal to, by the angle addition formulas that you can either derive using the technique described in our video on the angle addition formulas, or you can look up in a Trig reference sheet using your online resources or a textbook. This is equal to cosine of theta times cosine of theta minus sine of theta times sine of theta, which is equal to cosine of theta quantity squared minus sine of theta quantity squared. And we usually rewrite cosine of theta quantity squared or sine of theta quantity squared as the following. For shorthand, instead of having to write these parentheses, we usually rewrite this as cosine squared theta. These two are the same thing. So this is equal to cosine squared of theta minus sine squared of theta. Now, you'll often see this double angle formula identity, or this double angle identity, in a different form. Check this out. We know that sine squared of theta plus a cosine squared of theta is equal to 1. And this means we can rearrange this to say that 1 minus sine squared of theta is equal to cosine squared of theta. So we can replace cosine squared of theta with 1 minus sine squared of theta. And if we simplify this gives us 1 minus sine squared of theta minus sine squared of theta, which is equal to 1 minus 2 sine squared of theta. And we can do a similar trick by replacing sine squared of theta. We can replace sine squared of theta. Notice that sine squared of theta is equal to 1 minus cosine squared of theta. So we can do the same thing and say that this is also equal to, if we replace sine squared of theta with 1 minus cosine squared of theta, this is equal to, if we simplify, this is cosine squared minus 1 minus cosine squared of theta. Distributing the negative sign, we get cosine squared of theta minus 1 plus cosine squared of theta, which is equal to 2 cosine squared of theta minus 1. So all in all, we have really 3 identities that just came out of this one fact here that we also proved using the angle addition identity. We have that cosine of 2 theta is equal to cosine squared of theta minus sine squared of theta, which is also equal to 2 cosine squared of theta minus 1, which is also equal to 1 minus 2 sine squared of theta. Now, as a little advertisement for how we can use this in a calculus course, when you're going over integration, it turns out that it's easier to integrate something that's not squared rather than something that is squared, especially in the context of cosines and sines and trigonometric functions. So you might see something, and this is just an advertisement, you don't have to know what this means, but just sort of to whet your appetite for what's to come in your calculus courses if you do decide to take calculus, that cosine, if we were faced with, say, taking the integral of sine squared of theta, then check this out. It's hard to integrate sine squared of theta, but it's easier to integrate cosine of 2 theta, since there's no squaring present. So we can rewrite sine squared theta when we know that 1 minus 2 sine squared of theta is equal to cosine of 2 theta. So we can solve for sine squared of theta, and we get sine squared of theta is equal to, we subtract both sides by 1, and then divide by -2, we're going to get cosine of 2 theta minus 1 divided by -2, which is the same as 1 minus cosine of 2 theta divided by 2, because I just moved the negative sign to the numerator and then distributed the negative sign across the numerator. So it flips the sign of this -1 and it flips the sign of this negative, or the positive cosine. So check this out. Now I have that this is the same as taking the integral of 1 minus cosine of 2 theta over 2. And it turns out that this is much easier to take the integral of than taking the integral of sine squared of theta.